Are you an education policymaker wrestling with how policy changes affect student school allocation? Or are you a teacher struggling to match students to subjects based on preferences, grades, and limited class vacancies? If you're still drowning in manual spreadsheets or complex code for all these things, get ready to say goodbye. In today's video, we're going to take a detour from my class to see that it's possible to build an app that can handle both the policy reviews and the nitty-gritty of student allocation. So imagine you are a teacher and you've got a list of 100 students who just set for their year-end exams. You've got their subject grades, and they've also told you their ranked preferences for classes next year. But life is hard, and resources are finite. So each class has a vacancy. The economics of allocation is such that we need to apply not just student preference as a filter, but also student subject grades. Your task as their teacher is to figure out how to allocate students to their preferred subject combinations as far as possible. In Singapore, this is a real operational nightmare in schools every year. Teachers spend countless hours manually sorting and allocating students, double-checking and eyeballing Excel spreadsheets. And not just teachers, education policy officers too. It turns out that many education policy reviews also require us to see how student allocation to schools might be affected. For example, when the Singapore Ministry of Education reviewed the primary school leaving examination in the mid-2010s, Singapore changed from a 3-digit aggregate scoring to a broader 2-digit scoring system. As you might expect, the Ministry of Education likely had to review how this would affect the secondary one school admission exercise. But what if we could automate either the school-level policy execution or policy-level review analytics? Well, turns out you can. If you take a look at this Notion product backlog, I've actually created a set of 28 user stories that outline the sorting algorithm and policy rules of assigning students to classes based on a set of hypothetical policy constraints. Once I've written down the algorithm step by step as a set of user stories in Notion, I can then create a tool that automates and also visualizes this sorting process for me in Lovable. So I'm going to run the sorting process using the app I've created so you can see how the app works. As you can see, when I click run, the app cycles through each student, their scores, and their preferences. And then it matches them to the class based on the vacancies and eligibility criteria. Now I'm going to pause for a while. Notice how the tool can not only emplace students, but also reject students when they don't meet the eligibility criteria. I want to emphasize the importance of transparency and explainability. Whenever we automate a policy process or methodology, it's important that we get the tool to tell us exactly why decisions were made, so we can review things as they go along. For example, it's clear that Oliver Smith does not meet the requirements for computer science. And it's critical that we see that because his low STEM score was the reason. When a student doesn't meet the requirements for any class, we can get the tool to tag the student as exhausted, and then shift him or her to the back of the queue after the sorting for all other students is completed. All these exhausted students who are sorted only at the end of a queue are given a class that still has vacancies. But we can also get a tool to issue them an appeal ticket so that we can manage them on a case-by-case basis through interview or appeal. Now you can just download the CSV file and load it into your respective school systems. I want you to take note of the number of steps this has taken, a staggering 163 steps. If you're still doing this allocation manually by hand or using line-by-line Excel transforms, I encourage you to consider building your own allocation tool and have a go at solving your own problem. If you're worried about data sensitivity issues, you can always assign students anonymous ID values, rename the columns, and work with anonymized or cloaked data sets. That's one way you can still use this kind of tool without compromising student privacy. And if you actually manage to build a good prototype, you can always hand the code over to a government agency that has software engineering capabilities, and they can scale up the product for you eventually. I'm sure they will say thank you for putting in hard work rather than present all your endless requests to them. And that's really how we should be partnering our agencies within government. That's it for this video. Thanks so much everyone for sending me all your comments. This use case was sent to me by Kenny Sir, a math teacher from Singapore's Assumption English School. So huge shout out to him. I love use cases like this, so please, if you have interesting problems, send them to me. And if I can make a tool out of it, I'll also make an interesting video for everyone out of this. Okay, I'm going to see you back in my online class on Applied AI Product Management. See you there.